So yesterday we checked about Hdfs. So today we are going to look at few more things. So yesterday we saw the overall view of Hdfs and the distributed file system, and Hdfs, which is a distributed file system, and the distributed compute engine. So these are the two things which we saw yesterday. So today let's take this a little deeper, and from there we will start getting into installation, configuration, hands-on and on subsequently. Okay, so today's session we will get a little bit more deeper into the Hdfs and the distributed compute engine. So to go back to the fundamentals, Hdfs and distributed compute engine, it is nothing but creating a virtual view using all the resources on the machine and making them appear as if they are on a single machine. So that's what Hadoop is trying to do, which is Hdfs, distributed file system basically. So it's called the Hadoop distributed file system. So Hdfs. Now if you go on top of it, you basically take all the compute power and create a distributed compute engine. And what we are saying is, today this has been standardized to Yarn. It is providing a holistic compute engine. On top of it is where we say that we have different implementations of or the programming models for the compute engine. So you could do it in MapReduce. Let's say you want to do it in Spark. You want to do it in, let's say, graph processing. So let's say GraphX or something which you want to implement. So there is one more which is called Giraffe and so on. So different compute engine which works on a distributed cluster is basically what we are going to go for. And if you look at virtually, this is becoming a distributed data OS. Even though it's not very evident, but if you are seeing this, this is what is becoming the next level of distributed data OS. So any questions here? So now let's look at it. We will go a little deeper into how the Hdfs really works out. Okay. So before we get there, so Yarn is on top of Hdfs. There is a question that is Yarn on top of Hdfs or it coexists with Hdfs. No. Yarn is sitting on top of Hdfs. Okay, because you can have Yarn individually, but it will be of not much use if it is not in a Hadoop cluster. So Yarn is nothing but a distributed compute engine working on top of the Hdfs. Because if you want a distributed compute engine, you need a distributed storage which is associated with it, so that data local processing can happen. So that is the reason it has to be on top of it. You can obviously run independently, where you don't use the compute storage capability at all. But then, yeah, you are more going towards a grid kind of a model. Okay. So now what I'm going to show you is something how it all works. So you will be getting access to this machine maybe a day or two. I just need to create the user ID. I will be sending that out. So let me log into this machine. So currently Hadoop is all installed. So I'm not going to go through the installation and configuration and all. But what I'm going to do is I'm going to show you the virtual view. So this is the Linux machine where we have, let's say, multiple nodes. So if I do, let's say, ls, listing of the file, you see that there are a lot of files which are existing. Okay. These files are on the local file system. So these files are here. So the files are here. So this is, let's say, the local file system. Call it as the local file system. So you see the command ls. Okay. So what is putty? Putty is a client which is used to connect to Linux machine. I'll show you the diagram for that. Just one second. So ls, this is the, it's like in Windows, if you see what is the directory content, this is what it is. ls is the command for that. Okay. Now if I say Hadoop fs minus ls, so now I am doing the same directory listing but inside the Hadoop ecosystem. So what I am doing is I am viewing the file system from here like this. Okay, I am seeing the file system Hdfs from here. So when I am asking this view, what is the kind of listing? It will show all the data stored in the distributed file system. So it will not show anything which is in local. It will show files stored in distributed file system. So and these will be different. What you store here and what you store locally will be totally different, because this is going to be some information which is stored on the Hdfs but in the form of blocks. Okay, so we will see how this is happening, but I want you to physically see that there is two things. So I say slash, so this is my file system. I can go and say, okay, give me all under folder user. I can see the contents of user. Let's say I go into, I can see contents of the folder. Similarly here, if I want, I can say, let's say if I say like this, I can see, correct? It is going further and further. So this is basically what we are seeing from a file system perspective. So I hope you guys are able to understand. Anything which I store in Hdfs, I can see it through the Hadoop fs minus ls command. So this is Hadoop file system and minus is what you do, and ls. ls means listing. So here also you do only ls, listing, but here you do Hadoop fs minus ls. So this is the difference. Now let's take one file and put it. So let's say this is a file on my local file system. You want to see the content of the file? See, this is the file. Okay. Now it exists in the local file system. So let me create a directory in Hadoop. I am creating in one folder. Let's say, let demo exist. Okay, so the folder is created. Now if I see the content of the folder, I can see it like this. And I can see empty. Nothing is there in the folder. Okay. So now I'm going to take this file and put it into this folder. So don't worry about the command today. Just understand the concept. I am trying to put the file, this file. So this file which exists in local, I am putting it to Hdfs. Okay. So what I did, it's going through. Okay, it's put. Okay, I'll show you the file also. Don't worry. So what I did is, I took a file from here and put it from here. Like this. I took one file in the local file system and put it to Hadoop. Now when it puts to Hadoop, it will get distributed in this cluster. So it would have broken into some pieces and stored it here. So for some reason, let's call it is here, here, and maybe here. So earlier the file was in the local file system here. And now it is distributed to all over the place. Is the point clear? It's very important to understand this, that there is something like local file system and there is something like Hadoop file system, and both of them are separate. Okay. Now let's say the content of this file. Hadoop fs minus ls okay. So this is your file. I want to see the content of the file. Hadoop fs minus cat. In Linux you will do cat to see the file. Here you would do Hadoop fs minus cat. See, this is the content of the file. This was the content of the file. Okay. So I had done 3 commands. One is ls, then put, and then I did cat. These are Hadoop commands. Okay. We are going to see Hadoop commands separately. All I showed you was, yeah, it actually copied the file. So, okay. Shoot. So the file is copied because the original file is still here. Okay. And the file is still there in Hadoop also. So it's not so the file is there. Okay, so the file is there in both the base. Here also and here also. So just like in this picture, the file is here also and here also. But the only difference is, this file which is stored in here can be only accessed through the Hadoop file system. You cannot go directly and access it, because you will get only some broken piece of the file which you cannot understand. The file will be exactly the same, but it will be broken. Okay. So we will come to how this whole thing internally worked, how it got distributed, and where it is currently stored. So those are things which we will cover. Okay. So before that, I want to at least get this concept clear, that there is something called as a local file system. There is something called as a Hadoop file system. Now, let's understand how am I connecting. So I have a machine here which is my laptop. So this is my laptop. Okay. So to connect to Unix or Linux on the cloud, you download what is called as a putty.exe. If you search for it, you will find it. It's a very small program. You use that and you are making an SSH connectivity to this machine. So in putty, I am doing a SSH basically. So when I did all this, what I did is SSH, new session. See, it's an SSH on this IP. So this is the IP which you will be getting, and I am doing SSH on that machine and giving my user ID and password. So from this my laptop, I am logging into this laptop, this machine, and from there I am operating. I am giving the Hadoop command because Hadoop client is installed here. I can also run Hadoop from here. I can install the Hadoop client here, and in that case, from here only I can submit without doing putty. I can say Hadoop put from here in my laptop, and it will directly go to and do the stuff. Okay. So we'll see now the internals of it, but I'm going to stop here to ask any questions. Any questions?
Hey, Suresh, I have like 2-3 questions.
Go ahead.
Am I audible?
Yeah, you're audible clearly.
Okay. So my first question is when you are writing Hadoop FS, right? So and kind of putting a file in Hdfs, it has to internally connect to Nemnode and get the block details and all that. How does that happen?
Yeah.
That is my first question. I'll tell you the questions, then you can answer one by one.
The problem is I can't recollect all the questions, so I'll answer one.
Okay. Okay.
Sorry.
Okay.
Otherwise it just, so the first part is that yes, how does it internally happen? That is what we're going to see next. So just give me a few minutes. I'm going to drill it down further and say that what really happened. Okay. And we'll see it internally.
Okay. My second question is, you were saying the green blocks, right, in your diagram. Can we actually go and see that file?
Yes.
I mean, I know it may not make sense because it is splitted.
Yeah, we can see it. Let me show you that file in case it will be a little complicated for others to see it now, but let me show you the file.
Okay.
So there is a file location which says where is the data kept. So the data is kept in this folder. Okay. So I can go to this folder. There is current. This is the block pool. Go to current. Finalized. I'll show you all that later. Okay. So this is how the files are kept. Each of them are kept as a block. Okay. And each block has an ID. Now the file is broken into blocks and kept it here. And each file has a metadata as well. Now your question will be, hey, which block is my file? Correct? So there are two ways to find it. Okay. And how do you find which file is which block? I will show you later because that involves a little bit more commands. Okay. But we will eventually say that once we put a file into Hadoop, it's going to come and store into this location in the form of blocks, and we will be precisely able to find out which block belongs to which file. Okay?
Okay. Yeah.
So this is the location. Yeah.
Okay. Yeah. My last question is, you were saying the local of slave machines, right? Now, in a distributed environment, how much important this local area is? Because I mean, how does it really happen? Do we have any less space in the local area? Because we may not have individual access to all these slave machines, right? So what is the purpose of this local area? Now here we are actually logging into local and then replacing from local to SDFS. But in say in a 100 node cluster, most of the slave machines local will not be accessible, as per my understanding. So I just wanted to understand like what is the purpose of having a local there.
Okay, so a couple of things. First thing is, where is the OS installed? So if this machine has to boot up, okay, it cannot boot up from HDFS. it has to boot up from a local file system. So the first usage of the local file system is for OS related activity, OS storage, okay, then caching and other things which you really do it, correct? Swap space, temp space, all of those exist, and these are all taken there in the local file system, which a machine has to operate irrespective of whether it's in distributed or individual, okay. The second most important thing is, and which you will learn in subsequently, is that when Hadoop jobs runs, okay, there is some amount of local data usage for temporary purpose. Okay, so these are the two reasons why you need the local system. So the local file system is still there, okay, and the temporary data is stored. The last and the most important part of it is, and this is very, very important, is this file is also stored in the local file system. Only thing is, this green box is stored in the form of blocks, which is not, let's say I store a file into the local file system, it will be storing with my file name. If this green is also stored in the local file system, but only stored with the block ID as the name, which only Hadoop knows it. Because whatever I showed you the block here, this is in local. All these blocks are in local. So finally, if you see it, Hadoop is only giving you a virtual view. Storage is all in local. Only thing is, it stores certain blocks in the local and creates a virtual view of these blocks. While the rest of the system is used by the OS and for temporary space. Sudeep, I hope this is clear.
Yeah, sure. Clear. Thank you.
Okay.
Please here.
Yeah, go ahead, Sridhar.
Yeah, this blocks, when we are storing a file, we can restrict to go into a different, like, definite block, it automatically goes to every block.
Sridhar, your voice has been a little breaking, so not sure how I can interpret that.
Okay, can you hear me now?
Yeah, it's better. It's only your network which is a problem. But anyway, you talk.
Okay, when we put a file in Hadoop, it will automatically compute and store it in across all the blocks, right? It will split the file and
yes.
So can we restrict to go a certain part of the file to a certain block, or is it a Hadoop job? It will be automatically.
There is an algorithm on which how this block placement is going to happen. Okay, and that is called the block placement algorithm, which we are going to see it. What is the block placement algorithm? Okay, but there is nothing where you can say that I am going to put a file into Hadoop. Please put this chunk of the file only on this machine. Not possible. Okay, but understanding the block placement algorithm, you can precisely say that most likely it is here and here and here. Okay, so Sudipta wanted the question to be repeated and the answer. So just one second, let me repeat the question and the answer. The question was, can these block IDs, when I am trying to put a file into Hadoop, can I decide in which node these block IDs can go? The answer is no. You cannot decide precisely which block will go to which machine. On the other hand, you can know what is the block placement algorithm. And with that, you can make a fair guess that this is going here. Okay? But once it is gone, where it has gone, that we can figure out precisely. Okay? But how would the distribution happen? It's a algorithm. Clear? So now yeah, Sridhar, you have another question?
No.
Okay. So there are other two questions on the chat window. So I'm going to take those questions. What if the size of the file is bigger than the local drive? Okay, so this is a very good question. So that this is all questions which you should ask, because then it will be easier to close it. What if the file size is bigger than the local file system and big enough for Hadoop? Big enough for Hadoop means it's less than the overall Hadoop file system. For example, if this Hadoop file system is around, let's say 1 terabyte for now. Okay, assuming it was only 250 drives. Okay, so now here let's say the disk was around 250 GB. Okay, and here also 250, here also 250, one more was there. Let's say 250 GB. And your file is of, let's say, which you are trying to put, that file is around, let's say, 500 GB. This is his situation. So you have a 500 GB file, but the local hard disk is only 250 GB. Hadoop will be able to still put this file in without any problem, because Hadoop has the aggregated view of 1 TB. So 500 GB is less than 1 TB, so the data is going to go into Hdfs. Now what it will do? It will try to block and segregate it and put, and anything less than 250 it will try to put it here, other than that somewhere else. So this is how it will work. Okay. Now there is one more question on the screen. Should the path of data directories be same on all nodes, or can it be different on nodes? It is basically, what is saying is, I have shown the data directory path and we'll come to this, but for the question's completeness I will just, the path which I have used from here, the data node directory, can it be different on all the machines? Yes, it can be different, and it can be anything which you want. You can have multiple of these and so on. So it need not be the same. Given that answer, in production usually what we do is, we configure them through a central system. So usually tries to keep it same. Okay, but it is not mandatory. You can do whatever you want to keep wherever you want. So I am going to go to the next level of questions. If there are any questions.
Sudeep, Karthik here, I have a question.
Yeah, go ahead, Karthik.
In the previous slide, you mentioned that Hadoop stores the data in the local system, right? Okay, so there may be a possibility the end user can go ahead and by mistake delete that Hadoop file system. Is it possible?
Yes. So second thing, there is a terminology.
So how we will implement it?
Yeah, let me correct few things there. Okay. You mentioned delete Hadoop file system. Okay. You cannot delete a file system as such. You can delete a file. So it is only a terminology correction, nothing else. I know what you meant. Okay. Whether when I stored a file into Hadoop file system, can I delete the file? Not the file, but the blocks accidentally by going into the machine. That is your question. Okay. But I want to correct it, saying that deleting a Hadoop file system means wiping this whole virtual view off. Okay. And to wipe this, yes, there is a way to wipe this whole thing off also. So that is called the formatting the Hadoop file system. Okay. So if you want to wipe the whole file system, that's known as formatting the file system itself. Okay. Which we can do. But that is not your question. Your question is, let's say somebody logs into this machine and just deletes this block. For example, I am here as a root user. I have so many of this block. All of a sudden I decide, was this block, I don't like it. Let me move or delete it off. Block is gone. Okay. So what happened? File is now gone, correct? The block is here. I'm going to move it back. Just, it was only fun to show you that yes, the file can be moved, it can be taken, and it can be deleted manually. That is where security for Hadoop comes into play. So this directory is not accessible usually by anybody. Okay. So this is only accessible by the Hadoop in the system. Okay. So now if your directory permissions are protected, it's fine. I have actually given some additional permissions so that when I do training, I have to show the people some path and files, correct? So I have given additional privileges. But in production, this will be totally logged out and only the Hdfs user will be able to do it. An Hdfs user is not a logged in user, it's a daemon. So there is no chance that somebody can have access to this folder in production. Apart from that, there is lot of other ways to protect the overall Hadoop file system, and that's what we will cover when we discuss security in Hadoop file system. Clear? Karthik, I hope that is clear.
Yes, sir.
Okay. So,
Sudeep, one more question. In this conversation, you talk about deleting the distributed file system, right? So you say there is a terminology formatting.
correct.
Say, for example, 4 machines get connected to the distributed file system, and I decided to remove one of the machine from the distributed file system. So in this case, the formatting would be happen in the system that I removed it?
No. So when you remove the system, it's just a physical removal. There is no formatting, nothing. The blocks which are already consumed, the space which are consumed is still going to be there. If you want to clean up, yeah, you have to do it manually clean up. Or let the cluster, if you joins back to the same cluster, the cluster will manage it. To delete, clean up, whatever it needs to do, it will do it. Okay? But
Yeah.
if you detach it and go yourself, you have to handle the whole thing. Okay? And you can do a local file system format, yeah, that will take care of it. Okay? Any other question, folks? Okay.
Sudesh, I have a question.
Yes, Suresh, I have one question.
Yeah, go ahead.
Can a 500 GB file put in a 1 TB Hadoop file system?
Yes, I know why you are asking. If you are asking
Okay.
for because of a replication factor, then we will talk about that separately. Okay?
Okay.
Otherwise, you are fine from a 500 GB to 1 terabyte. Okay? In fact, you can do that in its raw form. Okay? For example, today I have 2 machines. Okay? And I set the replication factor to 1, then I can do that. The only problem is the replication factor. Okay? So that I need 3 times the storage. If I want to put 500 GB, I need at least 1.5 TB. Okay.
I have another question follow on. What if you remove one of the disks? Will the replication will automatically adjust in the remaining disks,
Yes.
or is
Yes.
it done?
Yes, it will adjust. If this space is still available, the free space on the Hadoop distributed file system is still available, okay, and there are under-duplicated blocks, and there are nodes available, it will do it, okay, and we'll see that. So don't worry, we will see those conditions properly. On what conditions the blocks will be replicated, under what conditions the block will not be replicated. So when I cover replication, and if I don't cover that, please ask that question. Okay, but the answer to your question now is yes, it will work.
Okay, thanks.
Okay. So Uday had a suggestion that we should ask the question at the end. The problem with Uday, the problem with that is what happens is at the end of it, if people start asking, some of the questions goes away. Second part of the problem is it becomes very monotonous. Sir, I speak and you guys don't speak at all, which becomes very difficult for me to continue and keep my excitement level higher. So problem is that. So I know that there are some questions which might not be always relevant, but in my experience in the history with conducting so many batches, I always found that when somebody is asking a question, everybody else benefits that much more than the person who asked the question, because I go into a little bit more deeper. I take it to the end view, what everybody should understand, and then I answer. So when somebody is asking a question, please listen to the question and also take the information from the question, because it has a broader implication. Okay, it's only in the initial period where the questions will be like scattered all over the place. Once we move to the understand the whole concept, the questions become so important that it needs to be clarified right and there. Otherwise, it becomes a little difficult for people to digest. Okay, so don't worry about that. We'll get there. With doing this for so many times, I have really mastered the art of how to take this forward. But yeah, it's a little bit annoying. I also know it. Okay, so let's go ahead. So coming back to, so if there are no serious questions on HDFS, I'm going to take this to the next level. Okay, so what I wanted to show from here was for you to have a feel of what I'm trying to talk about. So it's not about I'm just talking about some theory and going away. I want you to see this, that this is actually what is happening. Okay, and we will do more of this only when you are equipped to do this. So I have to enable you to ensure that you are able to go to this machine and do your stuff. So that is my journey. So in another 1 or 2 days I need to do that, so that I take you from to, so that you will be able to operate on this machine easily. And that's my initial goal. After that you can start practicing your sessions. Okay. So let's understand the internals of HDFS. What happens? So it is called the anatomy of a file system. File writes and reads into Hadoop. What really happened behind the scene? When I wrote a file into Hadoop, when I read a file back from Hadoop, what is really happening? So this is our goal. So we are going to reach here at the end of this session. Okay. So let me start this journey. So the journey will start saying, first let's build a cluster. Okay. So you gave me one machine and said, okay, this will become your master machine. Okay. So what I did, okay, I labeled this as a master machine. There is nothing like labeling as such. I might just change the host name of the machine as master. In this, I install Java, and then I install a Java process called nameNode. Okay. Then you gives me a set of bunch of slave machines. So I said, okay, I'll take, let's say 4 machines for now. Okay. And these machines are called the slave machines. And what I do is I install a Java process called datanode. Okay. Somebody is not on mute. Okay. I got it. Okay, so the data node here, there's a data node here. So it's basically a Java daemon which I'm installing and configuring. Okay, so this is a data. Now the data node should know the name node, correct? How does it know? Or name node should know the data node. How should it know? So if name node needs to know the data nodes, I need to configure each and every machine's IP address here. If I need to know data node to know name node, I need only the name node's IP here. So if I add a new node, I know what is the name node IP, I just need to put it here. So this approach is much better than doing the other approach. Keep on adding the name node IP list here. So the best way usually in distributed system is you call me. Okay, that's the approach. You call me and then I'll do it. I won't poll you. You always call me. So this is how it works. So each of these guys have a configuration file here. Okay, and this configuration file is called the core site.xml. Core site.xml. Now what is the location of this file? All Hadoop configuration files are stored in etc Hadoop conf, And in this file, there is a file called core site XML. In that file, we store what is the IP and port of the name node. So let's see that file. Let me on the cluster here, etc Hadoop conf. This is the folder. Let me clear it off. Okay, so this is the folder, and you see that there is core site XML, and you see that there is a property which I defined at the beginning, which is this is my host name. Okay, my host name is this, which is BDC training, that is called Big Data Coach Training. Okay, and 8020. So this is the IP and the port, basically host name colon port. You can give the IP address also, nothing big deal. So this is the configuration which is kept in almost all the machines. So this machine also has it, this machine also has the same thing. So you have the configurations. Okay. So when you have the configuration, when this daemon starts up, the Java daemon starts up, it is going to read this file and then identify where is the name node and register itself with the name node. So this guy will also register, this guy also will register, this guy also will register. So when it registers, it is going to tell the name node how much of disk space is empty on this particular node. So it will look at the local file system disk space. Okay, so this is the local disk which is there, and it will see how much is the free space, and it will inform the name node accordingly. So it will register and specify the free space basically. So this is two things. So name node is just collecting. Okay, name node got the information saying that okay, data node 1 has arrived from IP number this. Okay, so we'll call this as DN1, and it has, let's say, 1 TB of free space. Now it will say okay, DN2 arrived and it has, let's say, 250 GB of free space, and so on. So now it will add up all this space, and that becomes your virtual file system space available. Okay, so let's say there is 10 TB of space available. So name node will know that I am actually having 10 TB of free space. Okay. So now let's say I want to put a file into Hadoop. So I have my laptop here. Okay, so this is my laptop or any machine basically, and I am trying to put my file into Hadoop. So I have a file here. Let's say it's not a very big file. It's around, let's say, 250 GB or maybe 20 GB. Let's say there's a 20 GB file which I want to put into Hadoop. So whenever you want to put into Hadoop, you need what is known as Hadoop client. Okay. If you have Hadoop client, great. Otherwise, install it. Not on your local file system, on a Linux machine or something, it is very easy to install. So you need what is a Hadoop client. Just like if you want to connect to a database, you need a database client. Correct? The same thing is here also. If you want to connect to Hadoop, you need a Hadoop client. Now the Hadoop client is responsible to do a lot more things. So the configuration file is here also. This core site file XML which we talked, it is there, and even the client needs the core site XML file. Okay, so even the client needs the core site XML. So now in this core site XML you have the IP and port. Correct? So now when the client wants to connect, so it can look at this and it can also connect to it. Okay, so this is how a machine, the Hadoop client connects to name node. The Hadoop client uses the IP and port from the config file and then connects to the name node. Now it wants to store this file. Okay, that is his goal. So what the Hadoop client will say first? Name node, I want to store some file into Hadoop. And when you want to store a file, you have to give a location. So you give a location, let's say /user root July demo. That was the folder which I had given. So I am going to say, on this folder I want to store the file. For now, assume that the folder is already created. If not, we will create it later. We will tell you how to do that. Okay. So in this folder, I want to put this file. So when it contacts the name node will say, okay, this is the file handle. Let's say it returns back a file handle to the Hadoop client. The end user will not even know it. Okay. Only the Hadoop client will know there is a file handle. Let's say 1, 2, 3, 4, 5 or something is the file handle. Now the Hadoop client will start reading the file and it will start breaking the file into small chunks. Now this chunk is also a property which is available to Hadoop client. At what level the chunks has to be created. So there is a file called Hdfs site XML. So you can specify that in Hdfs site XML. Okay. Or it will take it directly from the default which is available to that. By default it's configured to 128 MB. Again, different distributions configure this differently. We'll come to that. But for now, assume that there is a block size of 128 defined as default. So this file will be first read, 128 MB will be read and a block will be created. The Hadoop client will then tell the name node, in name node I have one block available to me. So at this location, so name node would have made the entry for this location, user root July demo, and given the file handle. And at this location, the moment Hadoop client says I have a file, it will give it a block ID. Block 1, let's say. This is the block which we were seeing in the block ID. So it will give you the block ID back. So Hadoop clients gets the block ID back and it also gets the location where the block ID has to be stored. So Hadoop client will, name node will say block ID 1 right now should go into, let's say, DN1. So this is, let's say, data node 1. So it might decide that it should go to DN1. We will come to the replica later on, but when the name node gives, it might give, let's say I like this, 3 replica copies also it will give. All the places where the data has to be stored. So the name node will respond back with this information to the Hadoop client. That is DN1, DN2, DN5. The moment Hadoop client gets this, it will pick up the first item from that list and it will try to connect to that machine, data node. Okay, and send this 128 MB of data over HTTP to that data node. So finally the block has, so let's say this block was there. This was the first block. So this block will reach this place here. Okay. So it has reached here. It also has a block ID. It has a block ID of BLK1. And the Hadoop client will also give the other nodes to this guy. So it will tell it that it has, this block has to go to DN2 and DN5. Then what this data node will do is, it will forward this block to DN2 for replication. Okay, so it will get replicated in DN2 here, but with the same block ID. And this is very important to understand that the block ID is unique to the block and it will remain same wherever the block traverses. So the block ID 1. Now from here it will be telling it that it has to go to DN5 also. So it knows now it has to go to DN5. So as soon as the block arrives here, this data node will transfer that to DN5. Okay. So this is how the block replication is going to happen. This is how the file is going to get stored into Hadoop. So now the acknowledgement will come and so on. So acknowledgement cycle, we'll see it later. But now you know that a block is first broken down. A block ID is generated by the name node, and all the places where the block has to be stored is given back to Hadoop client. Hadoop client will do all the work for you. Then it will read the next block. Do the same thing again till it reaches the end of block. When it reaches the end of block, it will do the same thing, but at the end it will say, name node, I am done. When it is done, the name node knows now the file is actually stored properly. But name node will not make this available to anybody till the data node acknowledges back. So every time a block is stored, periodically data node is sending block reports to name node. Okay, so there is block reports which are going this way. So as the block reports goes, it will tell you that I am hosting this block, I am hosting this block, and so on. So there is a block report. So the whole trick is around breaking the file, assigning an ID, transferring it to multiple machines, and data node registering back to the name node with the block report. The moment the block report arrives, this confirmation is done that block is there somewhere in the cluster, the file is available. Any questions?
Sudeep, how does data node know data node 1 node, data node 2 and data node 5? Because they only have the name node.
No, this is the IP. It's the IP or the host name which will be given. It's not the logical name. Okay?
How does data node 1 know where data node 2 is?
It doesn't need to know. It knows only the IP. So even if I give you an IP, you can directly connect to that IP, correct? So name node is giving to Hadoop client the IPs of data node 1, 2 and 3. So Hadoop client is using that IP to connect. Similarly, this data node process can connect to that particular IP, correct? So it's a direct HTTP connection invocation.
Okay.
Over an IP. Okay?
What does FD12345 actually do in this whole?
It all does is because when the next set of blocks are also required, when the Hadoop client makes the next request, it has to say that on this file handle I need to get another block. Okay? Because the first block is got through. The next block when it tries to allocate, it cannot allocate on another block file, correct? It has to allocate on the same file. Because there are many parallel guys who are talking to name node. So name node needs to know who is asking for which block and for which file. So it will associate accordingly. So it was only to tie all the blocks or the session together. Clear?
Yeah, so it's some kind of file naming that it is storing with.
Yeah, it is not storing anything. It is just a temporary file handle. Unique ID for that file. Okay.
Hi Sudesh, I have two questions. The first question is like the Hadoop client, you mentioned that it's to specify the path in which they need to store the data, right?
Mm-hmm.
So how it's possible, like a Hadoop client doesn't know where the data node is and what path it has to store, right?
Correct. And even now also it doesn't know where to store it. The data node has the configuration which we just saw, the Hdfs site XML. In that location, it is known there where to store it. Okay. All data node is told that is, I have block ID 1. You please store it. It is your headache. So data node is going to decide where to store in its local file system and store it there. Okay.
Okay. My second question is that FD.12345. Say in our example, the 20 GB is split into 3 blocks.
Not
Okay,
3,
so
it
when
is
Hadoop client
20
requests the
GB.
name node,
20 GB
maybe
will
more
be
than
split
more than
by 128 MB. Okay, remember that.
yeah.
When-
So say for example in this case 3 blocks are being splitted. So Hadoop client request I need to store this 20 GB and it has 3 blocks. So the name node acknowledge it
No.
with fd.123, like the block 1 will go to this nodes, block 2 will go to this nodes, and block 3 will go to this nodes. As a single shot it will give, or each block the request will go to name node and then it come back.
Yeah, that is what I said. It is not the way you talked about. It is the way I have said it. That first time when it requests, okay? See, the thing is, the name node even doesn't know the size of the file, okay? And there is no size communication the Hadoop client is even passing to the name node. The first thing which it does is, it doesn't even ask for a block. All it says is, I am going to store this file in this location. Give me the file handle. Okay. So first time there is no block ID also created. Only the file handle is created. Okay. And name node even doesn't know what kind of size is going to happen. Because even Hadoop client might not know how much is the size. Because it need not be that it is a physical file sitting here. It can be a streaming client also, where somebody is just sending the data over the network to Hadoop client. Okay, so that could also be possible. So Hadoop client will never know, or it might not know what is the size of the file it is even going to store. So it doesn't matter. Okay, first it is going to ask for the name node to give a block. Okay, so the moment it gets the file handle, it will do now block by block copy. So first it will take the first block, then ask the name node, give me a block for this particular one. Then it will take another block, ask for this. Then it will ask for another one, and so on. So it is doing one at a time based on how much information of data it has. It is not asking name node to give upfront all the block IDs and everything. Okay, remember that, because you might be writing a, let's say, 100 GB file, and let's say it takes around 2 minutes for you. And when you started, there was 100 GB available on the cluster. But as you started writing, the other guys already used up all the things, because there are many other clients connecting. By the time you reach the last file, last block, it might be possible that name node has already run out of space, and it will give you back to you saying, boss, I cannot do anything for you, because there is no block allotment I can do, and it will fail. So this is how it will work. Okay? Karthik, I hope it is clear.
Yes, Sudesh.
Okay.
Sudesh,
Yeah, Sridhar.
yeah, so the block ID will be same for all data node blocks. So how will it recognize which is the original and which is a replica? It will be any ID stored? It doesn't need to.
All of them are identical. Okay. So there is no original and there is no replica. Everybody is replica.
Okay. And if the data is split into 3 data nodes, suppose I like data node 1 stored the first chunk and remaining to the one like 2 and 3. So if the data node 1 is down, how will the data will like calculate it complete?
See, the blocks are replicated, correct? The same block is available in 3 locations. So one node going down is not a big deal. For example, the second block comes in. So let's say you have got the second block coming in. Okay? No, sorry. So this is the second block which is coming in. Okay? Now what we are saying is, let's say this second block is going to maybe sit here first time. Okay? And it is storing here, let's say. And then another node somewhere else. Okay? So I'm not showing the third part. So it could be any combinations of these nodes which is storing the blocks. Now let's say if this goes down, this block is also available here. Correct? So this node can go.
Okay, one question like when we are storing it in 3 different data nodes, the data will be splitted, right?
Splitted means the same data is stored. It is not splitted. The same data is stored. This data is stored. This block is stored here, here and now here. This block is stored here, here and here.
Well, the entire data will be stored or only?
The entire data is stored. This entire block is stored.
Okay.
The file is broken into blocks and the blocks are stored. Okay.
Oh, okay. Okay.
Any other questions?
Sandeep, I have a question.
Yeah, Sandeep, go ahead.
Yeah, so the putty connection that you are shown, right? So you are connecting to a remote client, correct? Through SSH.
Through this one. Okay, when I did this, yes. But here I have not done any putty connection.
Correct. So that client which you are connecting, it is no other daemon is running like data node or name node, or is it possible that it can be name node as well or data node as well?
Yeah, it can be anything. It is just a Linux machine which has a Hadoop client. Okay, it can have anything.
Okay.
It doesn't matter. All I care about is Hadoop client. Once I want to put it, I can Hadoop client. So this it need not be your laptop. It could be the server which I connect to. Okay. So in this case, it could be like this. This is not the one. I am here. Okay. And from here I am moving here. Okay. So that could be the case. So in this case, this is the putty connection which I am making, and this is the Hadoop client machine, and this is my laptop. It could be that way. But what we are saying is, wherever Hadoop client is there, on their location you can use the Hadoop fs command to put the file into Hadoop. Now Hadoop client can be installed here, here and here also. So from here also I can put it into Hadoop. Correct?
Okay. And when I'm connecting to Hadoop client, I'm connecting to a particular ID. So whenever suppose you create IDs for us, we will connect with our IDs.
Yes.
So how does when I'm doing Hadoop fs -put, right? So does the same, it uses the same ID to connect to name node and data nodes and do the operations, or does it use separate some daemon ID?
No, it will use the same ID. So that we will come to in some time, okay, where we will say that the Hdfs file system doesn't have a user management of its own, okay. It borrows the user management from the Linux file system. So we will talk about security and user management and all of those separately, but when we do that, we will cover that, okay. So right now, if you as a user is connecting to that machine's your credential is basically what is used by Hadoop to get going. So there is a little bit of complexity. It is not that easy. So we will come to that in the subsequent sessions. Okay.
Sorry, I have a couple of more questions.
Go ahead.
When we are when it is copying data, every block when it is replicating. Suppose in the last block, correct, when it copies, there may be some network issues, etc. And it is, though it has maybe copied it, but it may have some corrupt data, etc. So does it internally recognize that when there is a corrupt block, and how does it do that?
Yeah, so there are 2 or 3 things which happens there. One is when you move the data across, there could be possibility that the data node dies off. There could be possibility that the data blocks are corrupted and so on. Correct? So there are 2 things which happens in this whole system. One is there is something called as the minimum replication factor, and everybody should remember that there is a minimum replication factor. So when you have a minimum replication factor, it by default is it configured to 1. So what it essentially means is, if one node is able to successfully store the file, I am going to call it as a success. So this is the default setting. So in a 3-node cluster, even if your other 2 nodes are not there, even if one node is acknowledging back saying that okay, I am good, the Hadoop client will say it is a success. Now when the other 2 nodes comes up, the name node will automatically take care and replicate the whole thing for it yourself. Okay, so you don't need to worry about replication, under replication, over replication and all of those. The name node will take care of it. The only requirement is for a block to be successfully stored, an acknowledgement from one node is absolute must. Okay. Now file corruption detection and all of those, there are a lot of methods within the Hadoop itself which follows the checksum and so on, and it has the checksum done at when the file is transferred, when the file is stored and all of those, and that will ensure that the file is stored reliably. Okay, so there will be no corruption as such, and if the corruption exists, the metadata will not be in sync with that, because you saw the file, there were 2 files which I showed you when I went here. That was metadata file was there. Okay, so for example, this was the metadata file. This file has the checksum for this particular block. So when it reading this block, if the checksum doesn't matches this file, then it will reject that block and try to see if there is any other place where the checksum and the file matches. So that is how the reliability inside a Hadoop is maintained.
And the checksum is also stored in the data along with the...
Yeah, here this file is the checksum file basically.
Okay.
Meta. So this is the actual block and this is the checksum file. Okay.
Okay.
So I hope
And
the minimum replication factor is clear to everybody, because I was going to cover that. Now since the question had asked, I have covered it there, saying that it is the minimum replications which needs to be acknowledged by the data nodes before the Hadoop client can declare that the file has been success. So a client user which is connecting to Hadoop client to save this data will get a success message only if one of the data nodes is able to successfully acknowledge the block. Clear? So there are so many questions on the screen, but I will just, yeah, Sachin, you can go ahead. Sandeep.
yeah, and is it possible for us to actually go and see the name node and metadata?
Yes, we are going to see all that. All that is going to happen. We are going to rip it off, so don't worry. As we scale through up, we will see the name nodes metadata will go intern. If you want, you can even change the name nodes metadata. All that will happen. Okay.
All right.
So we will be ripping it off fully. So this is not the end of HDFS. I am saying I am going to take you to HDFS at least for 1 week. Okay. You need to understand a lot more things in HDFS before you declare HDFS is done. So this is just the introduction. We are just getting there. I have just booted it to 1 level now. Okay. So any other questions? Otherwise, I am going to go on the screen. Yeah.
Satish, one question.
Yeah. Go ahead.
You mentioned that minimum replication factor is equal to 1. Okay. Let me consider this scenario. In this picture, the first block is allocated to data node 2 and 5. Okay, so it got a FD block from name node to the Hadoop client, and it starts sending the data to data node 2. And it receives data node fully receive the block, and it sends an acknowledgement as a block report to name node. And when it started transmitting the data from data node to data node 5, the data node 2 become lost, the connection got terminated, or some node went down. So the replication factor didn't happen. And the data is not stored in the data node. How are we going to handle this situation?
There is nothing to handle in that situation, because see, the case is when a Hadoop client stores the data into first block, okay, it got the acknowledgement. It might say that file is stored, I am going ahead. Okay, the block report also went back, which essentially says that name node has understood that the file is up. Okay, Now, when it transferred, this guy didn't acknowledge. So the name node knows that this block is not here, this block is not here. Okay. But name node knows the status of DN1. If the name node DN1 goes down, okay, it will mark all the blocks which are associated to DN1 as corrupted. Okay. And it will also declare the file as corrupted if that was the only block available. Okay. And it will, you can get a file report out of that. Okay. So it is not going to do any magic there. It is only going to tell you that boss, this file is corrupted. If this block comes back, I am going to give you the file, otherwise forget it.
So will it send a report or to send the Hadoop client or the concerned user like this block of data got missed out?
No.
Failure or something?
No, it won't. You have to run a Hadoop admin command to figure out which are the blocks which are corrupted. Okay? Node is not going to notify anybody, anything.
Okay, then I put my question in another frame. Okay, there are two file requests, say for two users who try to store the data in the Hadoop. Okay, so user 1 and user 2. User 1 try to store a data of maybe 1 GB data. So it has been blocked into six, for simple example, consider 5 blocks, 1 GB. So 5 blocks of data is available for 1 GB and it's stored in the distributed data nodes. So for out of 1 GB, 1 block got missed out in the data node and it's not, replica was not available. Okay, and the name node is marked as data node is corrupted and we can run a report. So this node is got corrupted, this block of data got corrupted. So how could I figure out I want those data back? So as an admin, can I figure out like out of 1 GB, this is the block where I have to again come back and store those data?
Yes, you can do that. And when we do the block tracement, we will say that this is the sequence of the blocks. These are the individual blocks. This is the corrupted block. All that will be identified. And you can precisely say this is the block ID. You can do a file system search on the data node which has gone down with the block ID and see that okay, I can recover that particular block. And if I can copy that block into some other data node, okay, and boot it, it will start up with that block. Okay, you can do that experiment. I will show you how to do it.
That answers my question, Suresh.
Okay. Fine. Great. So now that is clear. So each one is a block. Just remember that file is broken into blocks. Blocks are stored individually. Blocks has its own uniqueness. If the block is lost, the data is lost. But if the Hadoop will always ensure that it is reliable, that it will not acknowledge till it is returned physically to the file system. Now your file, if the disk is corrupted, you can't help it. If the disk is not corrupted, the node going down, it will, when it comes back up, it will join the cluster, no problem. If the disk is corrupted, you need to ensure that you have copy available. So if you are too worried about your data, then increase the replication factor, minimum replication factor to 2. So it will at least ensure that it will not commit back till 2 copies have said that I have stored it. So in that case, you have a fault tolerance of at least 1 node. Okay. So by default, the replication factor is only 1. But you can bump it to 2 if you are so worried about your data. Okay. And in that case, there is a slight performance overhead because the Hadoop client will have to wait for 2 acknowledgements to come before it will say that the block is successfully stored. So it's a choice on how you set the minimum replication factor. Okay. So now I'm going to go ahead.
Shradesh, one more question.
Yeah.
Okay. Say for example, the block 1 is trying to store in data node 1 and data node 2. So it got an instruction from name node, it's going to store it. So when it starts to send the data to data node 1, so data node 1 got disconnected from the...
It will retry. It will retry to the other nodes. It already has the information about all the 3 nodes. So if data node 1 is not available...
If all 3 nodes was down during that time, what will happen? again
If all
Hadoop
the three
client
node
will
is
send
down,
one
it
more
will
request.
not save the file. It will just give the error to the customer. Okay. So if the 3 nodes are down, it will give the error. Okay. It will retry 3 of those. It will give. Then if you retry it, you will go back to the name node. Name node might give a different nodes at that time, and it might get succeed. Okay. But it will not go retry on the same node. So once a block is assigned from the name node, the 3 data nodes which it has, it will try one after the other. And if all the 3 are down, it will just shut up and keep out and give out an error. And then you will have to go and initiate another connections to the name node to get a new set of name node. Okay.
Thanks, Satish.
So now let's go and look at all the questions on the screen so that all the other set of questions are answered. There are a lot of questions there. So let me tell you. So first question are the FD 1, 2, 3, 4, 5 session identifier. So for each file this will be different handle. Yes, this is a different file handle, and one thing which you need to know is that this is not seen anywhere. Unless you debug your Hadoop client code, you will not see this file handle at all. So don't get bogged down with this and start searching for this. This doesn't exist. It is a logical number which is available when the first connection is made. So don't code this anywhere. It doesn't exist. It is inside the Hadoop client as a part of the function call. Okay. Next question. Does the user gives DN1, DN2 and DN5 IP address, or the name node it gives it? The name node is giving it. User doesn't do anything. Okay. When the user booted up the data node 1, data node 2, data node 3, the data nodes registered itself to the name node and gave its IP to name node. User will never give any IP of the data nodes. Data node will self-register itself to the name node because it has the IP of the name node. And when it registers, it will give its IP or host name to name node. So when the blocks are requested for, that IP or host name is given to the client. And that is how the client will reach out to the data node. I hope that is clear. Jitendra. The next question is, in core site XML, whether we will give the name node name or the data node name. In core site name is only name node. There is no data node. If you have to give data node, it will be like thousands of nodes. So please don't think that data node IPs has to be given. If it given, then you are in trouble. Okay. So the next one is, I just want to know whether Hadoop client will connect to name node or data node. Hadoop client is connecting to both. First it is connecting to name node to get all this metadata, and then it is connecting to data node to transfer the file. Okay. Now there is the second question is, if it is data node, then whether we will have a common name representing all data node? No. There is no common name for data node. It is always identified by the host name or the IP address. And Hadoop client has to precisely connect to one based on what name node is instructing it. Name node will instruct it by passing it in an order. DN1, DN2, DN3. So it will go in the same order, the Hadoop client. Okay. So next question is, in core site XML, whether we will give the name node. That's fine. That is done. Next, how does the name node knows if it has received the last block of the file? Yes, when the last block of the file is received, the Hadoop client will tell the name node that, boss, I am done with the file. So you can close this file handle. Okay. So that message is sent by the Hadoop client to the name node. Once the acknowledgement of the last block is got to the Hadoop client, it will send saying that, okay, I am done with the file. You can close this file handle. And that's the time where the file becomes available to others. If the handle is open, nobody can touch that file, because only this Hadoop client will be able to touch the file. Okay. So that's the reason why name node will be told that it is the last block of the file. Okay. So I think all the questions are now answered. If there is still, Shiva, if your question is still not answered, let me know. All other questions are answered on the screen.
Suresh, I have a few questions.
Yeah, go ahead, Sudeep.
Yeah, I'm not clear about the acknowledgement and commit part. So,
correct.
If you can repeat that.
Yeah, we will go into the acknowledgement part next. Okay, so usually we do this 2 times so that people will understand it very clearly. So I'm going to do the second time now so that the whole process is very clear. and in the second time I am going to bring the acknowledgement piece into mix. So let me start again. I have a file. The file is of 20 GB. I want to store it into Hadoop. To store it into Hadoop, I need a Hadoop client. Okay. Now Hadoop client needs to know the data node and the name node. So it will only know the name node at the beginning. How will it know? Because it has a core site XML. In the core site XML, name node's IP and port is defined. So Hadoop client can connect to the name node. Now, when we have to store a file, we will always give where to store the file and what is the name of the file. So Hadoop client will make the first call to the name node and say, I want to store this file in this location. Name node will do one check. This I have not told earlier. Name node will do one check, which is to ensure that the guy who is saving this file in this location, does he have the required privileges? So this is the check which happens here. Okay. So the first check which happens is whether user have permission or not. And how the user have permission checks, we will come to that separate. But there is a check done here. So let's assume this user who has logged in through this Hadoop client has access to this location to store the file. Then name node will say, okay, great, I am going to register the file name there. And it will not assign any block ID or anything. It will just generate the file handle for that location and give back to Hadoop client. Now in parallel, Hadoop client would be already reading the file. As soon as it reaches 128 MB, which is nothing but the block size, it will say, okay, now I am ready for one block. Let me contact name node and say, where should I store it? So the moment you connect to name node will give you IP address or the host name of 3 of the data nodes, assuming there are more than 3 nodes in the cluster. If it is only one node in the cluster, it will return one node back. If there are 5 nodes in the cluster, 3 will be returned back. Okay. So it will come back to you in the order in which name node would expect that you will do load balancing. Okay. So name node has the algorithm to figure out who should store where and when. And as soon as it understands that, yeah, DN1 has to be stored, the Hadoop client will connect to the data node at that first one and stream this file. And I am saying it is a streaming. The file is streamed over HTTP to the data node. Once the file is streamed to data node over HTTP, the data node will start storing the file in the corresponding location. And that location is specified in the Hdfs site XML in the data node. So Hdfs site XML, there is a configuration where it says what is the data node location. In that directory in the local file system, this particular block is saved. The moment it is physically saved, it will start acknowledging back to Hadoop client saying, I have got this block. At the same time as the file is streaming and it is saving, parallelly it will stream it to the next node, which is DN1, DN2 and DN5. So first it will go to DN2. Okay. And the data node 2 is also started saving the file into the disk. If as soon as DN2 is done, it will acknowledge back to DN1 that I am done saving the file. The moment DN1 acknowledges here, this guy will forward that acknowledgement of DN2 back to Hadoop client. So the acknowledgement cycle is like this. It goes from here to here and then it goes back. Okay. So if you want a colorful diagram there, let me draw that. The acknowledgement cycle is in purple now and it is going like this back. So this will go and the acknowledgement will go from here to here. Similarly, when this guy forwarded the request here, the acknowledgement will come back. Okay, so the acknowledgement from here, oh, I think this is some mess. Okay, so the acknowledgement will come from here to here back. Okay, and from here to here and then here to here. So if there are 3 acknowledgements required, so this will go here, here, here. So this is the acknowledgement life cycle. Storage life cycle is here to here to here. Acknowledgement is the reverse of that. And Hadoop client gets it one by one acknowledgement. Okay. And as soon as the first acknowledgement comes in, it doesn't care about any more acknowledgement because the minimum replication factor is met for it. It will go to the next block, do the same thing. Do the same thing, process it, come again till it reaches the end of file. Again for the last block also it will do the same thing. But once the acknowledgement comes for the last block, it will say to the name node, I am done with the file, close the file handle. So the file is closed, it will be moved out for everybody else to view it. Till that time, nobody else can see the file or take the file out of Hdfs. When the file is getting saved and the file handle is not closed, nobody can see the file. Any questions?
Yeah, it's clear, Sadish. I have a few other questions. So when you are saying file handle, so it's basically a unique identifier for a file for Hadoop client to communicate with name node in different time stamps, right? I think it will be a multiple times client would be communicating with name node for a particular file. I think for that it keeps it. Am I right?
Yeah. So that's just a file handle, which is just to make sure that the client is able to tell the name node that I am coming. Okay.
Okay. My next question is when you are actually writing command like Hadoop FS. So does it internally connect to Hadoop client or it itself a Hadoop client?
Sorry, I didn't get that question. Can you repeat?
So my question is, say I have to place a file in Hdfs using PuTTY. I connect to the machine where Hadoop client is installed. Now I am writing a command, say Hadoop FS, put a file name, whatever it is. Now what this Hadoop FS does is it when I write Hadoop FS, it internally connects to Hadoop client.
No, it is a Hadoop client. Hadoop FS is a Hadoop client. Hadoop client, yes. Hadoop FS is a JVM basically. So it's a Java process. Okay.
Okay.
So what happens is, let's say you have a Oracle database and you want to connect to Oracle. Okay. So what do? You install the Oracle drivers on your machine. Okay. And then you write a small client which will use that driver to connect to Oracle. Correct? So that is the same thing here. So to connect to Hadoop, you have all the libraries of Hadoop which is available and a small utility program which is written on top of it for you to interact with that program. That's the command line client. Got it?
Okay.
So basically it is nothing but a JVM. Okay?
Okay. Yeah.
Okay, so Jewel had a question that is there a time limit for receiving the acknowledge from data node to client? Yes, there is a timeout which is defined. Before that the acknowledgement has to come. Otherwise it will say file cannot be saved. Okay, so that acknowledgement you can define in the Hdfs site XML. And by default it is already there. I think it is around 20 seconds or something like that. So the retry part of it, okay, when let's say when you are trying to store it to a data node and the data node goes down and hence the acknowledgement didn't come, okay. So the retry is like if one node is not responding, try the other node, okay. Now it will never try the same node again because it will try to, because it already has 3 nodes to try. Why would it try the same node again? If one node is not responding, get lost. I am going to go to another node. That's the model. Okay. With ACK fail, see ACK acknowledgement from the data node back to name node and back to the Hadoop client is not a weighted process. It is an asynchronous process. That is, if you give me acknowledgement, I will take it. If you don't give me the acknowledgement, I will not take it. That is the model. Okay. So I will keep looping and waiting for it, the acknowledgement to come within a time period. If I am not going to come back to you and say give me acknowledgement or so on. You are a data node. You are responsible. Once you save it, you are supposed to acknowledge me back. I have put a timer and I am going to wait within the timer. If you don't respond within the timer, I am going to go ahead. Okay. So that's the model it goes through. Clear?
Hey, so just I have a question.
Yeah.
So suppose I'm writing a file and at the same time someone is trying to read it. So will it be able to read only after I write all the blocks, or?
Yeah. Only after all the blocks are written, the file is available. Otherwise, the file is not available.
Okay. Okay. And I missed one part. When you said replicating blocks, right? So after I write the first copy and then it is replicating it, is the replication parallel or serial?
The replication is parallel. No? It's like, see, when it is writing to this block, it is writing, at the same time it is replicating. Okay. Similarly, another block is also going to come to another node parallelly. It is not going to be sequential at all here.
No, no, I'm asking for the same block when it is saying that it has to replicate to dn1, dn2 and dn5.
That is sequential. That is sequential.
Sequential.
It is, yeah, it is sequential. It is not parallel. Okay. So it will go to dn2, then it will go to dn5.
Okay. Thank you.
Okay. Any other questions?
Yeah, sure. I have a few more questions.
Yeah, go ahead.
Yeah. So in typical cluster, how many clients are installed? I mean, how many machines those are installed?
That is not like Hadoop client is installed mostly everywhere. So there is a lot of clients. Okay. So there is when we look at the topology, we will talk about where specifically you need to install also. Okay. And so I will cover that separately when I discuss the edge node and the topology and so on.
Okay. And my last question is, when you say local and Hdfs, right? So admin would be able to specify the space, how much you should be keeping for local and how much you should be keeping for Hdfs. I mean, is there something?
Yeah, that yesterday we covered. What we said yesterday was, when you give the local file system to Hadoop, okay, there is something called as reserved space. You can always reserve a space for your local file system and say that in this hard disk, let's say 20% of my data should be preserved for the local operations. Okay, and only 80% should be given to Hadoop. That you can do it. That is called DU reserve space. There is a parameter in Hadoop which will say that before Hadoop allocates anything, this much space should be reserved for the OS to operate. So it will never fill up that much space. Okay?
Okay, yeah, thanks.
Okay, any other questions? This is an important session. I hope you understand the internal details of Hadoop to some level. Again, I usually go a little slower here because you need to understand every bit of it. So tomorrow we'll continue further. I don't want to again bog down and take up a new topic here. So today we covered the anatomy of a file read and write. So read we have not done. So let's do that quickly, because on this picture it will be very easy to cover the read also. And then we will stop. Okay. So now we have stored the file. We want to get the file back. Okay. So let's say there is another Hadoop client now here. Okay. And I want to get my file back. So I am a Hadoop client here. I have the same configuration file and I want to get my file back. So I know where I have stored the file, correct? So I will contact the name node and say, name node, at this location I want my file back. So what he will do? He will look at all the blocks and say, this is the location where you can get your files. Block 1, at this location dn1, dn2, dn3. Okay. Block 2 at dn4, dn5 and so on. You can get wherever you want. It will just give you all the block information. The Hadoop client will go block by block and start contacting the first guy in this list. So for the block 1, it might reach out to this guy. For block 2, it might reach out to this guy parallelly. For block 3, it might reach out to another guy parallelly. So all these blocks will be requested to send their information parallelly. Now this guy will give his block back. This guy will give his block back. This guy will give his block back. Hadoop client on receiving the block will start assembling the file back into the final block. So it will start assembling one by one file and putting it all together, the blocks. Okay, and then give it back to the customer. Now in this case, let's say this data node 1 is not up. It will switch over to the next guy. If data 2 is not there, it will switch over to the next guy and so on. But it will take all the blocks. Once all the blocks are returned, it will reconstruct the file and give it back. So this is a very simple process. Reading the file is very simple. It is all parallel. Gets the block information from name node. Just fires all the parallel threads. Get as much it can get it and just goes. Okay. Any question? So reading is very
like when you ask for the file.
okay. Go ahead.
Yes, Suresh, I have one question, Sandeep. So when it is reading the blocks from data node, does it use like checksum value and then?
Yeah, it will verify the checksum. Every time a block is hand over from the node to, so data node, when it reads it, it will verify the checksum. And it will also pass the checksum back to the client. When the block is gone back to the client will also verify the checksum and then only give it back. Okay. So if there is any corruption, it will ask for retransmission or it will go to the other node and pick it up.
Oh no, thank you.
Okay. There was one more question somebody wanted to ask. Please ask.
Yeah, Suresh, when you ask for the file, will it, the name node itself will create the one file and it will give it back, or we need to assemble the file?
See, name node is not assembling anything. Name node is only giving you a list. Remember, there is no data movement to the name node. First of all, get your terminologies right. Okay. Name node is not touching the file at all. Name node is only working with metadata. Now, the metadata about this is given to Hadoop client. Hadoop client is responsible for assembling the file. Okay. So the entire assembly is happening at the Hadoop client.
Okay.
Any other questions?
Yeah, Suresh, I have one question related to checksum. So, when client receives blocks from multiple data nodes, it receives blocks as well as the checksum. And then it calculates the checksum for a particular file and then it compares calculated checksum with the received checksum from different data nodes. Is my understanding correct?
See, the block is transmitted and the checksum file is also transmitted. Okay. So,
yes,
all it does is it recomputes the checksum on the data and validates that the checksum file it has received is the same as the block checksum. Okay, and then it goes.
I mean, client itself recomputes and compare, right?
Correct. Client will recompute and compare. Okay, client will compare, even data node will compare. Before rendering also, data node also will check.
Why data node has to compare?
Because it might be that the file is corrupted right from the receiving end itself. So data node can even reject not transmitting it. Correct.
Okay.
See, if data node is transmitting that, it has to be sure that boss I am transmitting the right file. Correct? Otherwise, it can say I cannot transmit. My blocks are corrupted. And then it will go in the block report and it will tell that to the name node that blocks are corrupted. So then name node will initiate a repair process separately.
Okay, so you're saying whenever a data node starts transmitting a file, even before transmission, it basically computes the checksum, compares the checksum, and then it compares sends it to client. And from client end, the same process repeats by client.
Correct. It just because see, as it is a streaming operation, correct? So as you are receiving the bytes, you can do the checksum on the fly.
Yeah, I got it. Thanks, sir.
In the same thing is what is happening at the data node. As it is streaming the file, it will do the checksum to see that the file blocks are fine and so there is a periodic check verification also which is initiated, which is not like periodic in the sense like every day or something. Every 10 days or 20 days, I think there is a process which goes behind it which will verify the checksum, and there is a report which you can get out of that also. So for any silent corruption, it has its own checks which does. And then name node will automatically replicate all the silent corruptions automatically.
Okay.
Okay, so now let's go to here whether all the blocks will be reconciled by reducer in distributor. Where is the reducer coming, Jewel? I have not even talked about reducer. Distributor, and it will return to client. It will reconcile to the meaning my file with me. So there is no reducer here. Okay, this is just a Hadoop client. And a Hadoop client is just a receiver of block. No, I am not able to hear you, Jewel. Something is not right. Okay. Irrespective of that, I understand what you want. If the terminology is wrong, please don't use the word reducer here at all. There is no reduction or consolidation happening. It is a Hadoop client. Hadoop client is taking the file, merging it together and putting together. So there is no reduction. Reducing is a different operation altogether. So terminology is important. I hope that is clear. Okay, I'm still not able to hear you, Jewel, so can't help it. So coming back, so I think today we covered the overall operations of Hdfs from a file read and write perspective. Okay, so this is one of the important sessions where you need to know how the internals works and where it goes and so on. Okay, so I hope this was useful to you guys. You will be able to review this, read through it, understand it, and in a couple of sessions we will see this in action. We'll go to the system and we'll see all of this process happening into it. But you need to understand the fundamentals, so that is where it was scheduled. Okay, so don't worry, it will, in the initial period it will be slow. It will go a little slower, and I am also adjusting to the pace of the questions and so on. So don't worry, it will be all covered. We'll be there. So tomorrow we'll look at a little bit more deeper into replication. We'll look at high availability, federation, and some more concepts around Hdfs. Okay, thanks.